Hey class, this is Mr. Roberts at Shasta High School, and tonight we're going to be looking at questions 108 through 114, all in Chapter 8. This first question involves something I find disgusting. I'm thinking maybe just throw them all away on the first day, but no, you're going to save some of the moldy egg salad sandwiches. Ew, Hannah's volleyball team left their egg salad sandwiches sitting in their lockers over the weekend. When they got back on Monday, they were moldy. Perfect, said Hannah. I can use these sandwiches for my biology project. I'll study how quickly mold grows. Using a transparent grid, I guess she took off and she like laid it over the sandwich, and she estimated that about 12% of the surface of one of the sandwiches had mold on it. She threw that sandwich out, right? Goodbye, you. For the rest of the week, Hannah came back when she had time. Each time she measured somebody else's sandwich and threw it out. She collected the following data. So these numbers right here are the percent of the sandwich that was covered in mold. So you can see day 1. Day 2, she apparently measured 2 sandwiches. One had 15%, one 13. Day 4, she measured 3 sandwiches, and on day 5, she just did the 1 sandwich. So it says create a scatter plot and sketch it. Is a linear model reasonable? So I'm going to it's been a while since we've looked at this, but let's go ahead and do this with our TI-84 calculators. I'm going to go ahead and hit stats and edit to edit some data here. And you can see X is going to be my X values will be the day number. So I've got a single day, right? And then I've got day 1 happens once, and then day 2 happens twice. So day 2, day 2. And then I've got day 4 happens, I think, 3 times. 1, 2, 3 times. And then day 5 happens just once. So I put a 5. And then let's get the percents, the corresponding y values that go with those x values. So the first one is 12%, and I'm just going to say y's are expressed as a percent. So I'm just going to run as whole numbers. So I've got 12, I've got 15, I've got 13 also on day 2, and then I've got 26, 27, oops. That's going to be awkward. That's going to be very large. Let's see. 26, 27. And then what do we got? 24. And then on our last day, day 4, we've got 38%. So I'm just kind of reviewing these numbers. I've got let me go back up at the top. Day 1, I've got 12. Yep, 15, 13, 26, 27, 24, and then 38. Day 1, 2, 2, 4, 4. Okay, so now that that data is in there, I'm going to go ahead and set up a stat plot. It's been a while since I've done it. I'm going to hit second stat plot. I'm going to turn this plot on. It's a scatter plot. My data is stored in list 1 for x's, list 2's were in y's. And I'll put this dot here. The other thing I'm going to do is I'm going to hit zoom, and what is it? I think it's zoom stats. It's pretty far down here. It's yeah, zoom 9, zoom stats, and there's our data, right? So you can see it, and I feel like there's a curve here, right? So I probably would not pick a linear model for this data, and if I was to go ahead and look at the residual plot, it would probably accentuate this fact that there's kind of an up down up pattern going on. And I'm thinking here, I didn't run a regression, so let me do that. So if I was to hit, I don't think a linear model is appropriate. So I'm gonna run a regression though. So I'm gonna hit stats, calculate, and I'm gonna hit a linear regression anyways. Good. So boop. There it is. So if I was to turn that equation on, I think to grab the equation I hit vars, then I go down to statistics. It's an equation, and it's my regression equation. So if I turn on that graph now, there's the linear model, and I can see, because this is above and then these points are below and then it's above again, you can see there's a curve that's implied here. But that's still not the residual plot, so I want to do the residual plot. By the way, this is all bonus. If this is uninteresting to you, please just zoom past this. If you think you should review this, stick around, but I'll be doing question 109 in just a sec. To get the residual plot, I'm pretty sure that's in second stat plot. Yeah. And what did I do? We did, I know what we need to do. I need to go to stats, edit. There we go. And I think we added the residuals in list 3. So I put my cursor up here. And to grab the residuals, it's a list. So I'm going to hit second list. And there it is. It's number 7. Boop. And I just grab it. So those are the residuals. And you can see the residuals positive 3, and then there's several negative residuals, and then it's positive again. So that's that pattern I'm seeing in the residuals. I'm going to hit second stat plot, and I'm just going to turn off this plot, and I'm going to go over to plot number 2, and I'm going to turn it on. And I'm going to, instead of doing list 1 and list 2, I'm going to do list 1, and then I'm going to ask it to look in list 3 where the residuals were. So it's going to plot the x values against the residuals. I'm going to zoom this again, so I'll hit zoom, and oh no, that's not, let me quit this. Oh, I don't know what I did. Let me go back to that. No, that's correct. So I can quit this. I'm going to hit zoom. 9 is this. Okay, there we go. So you can see that there's a positive residual on day 1, and then there's like negative residuals, and then there's positive again. So when we see that kind of high, low, high pattern, it's an indication that a linear model is probably not the best fit for this. So it says, based on the story, what kind of equation do you think will best fit the situation? Okay, fit the data with an exponential model and write the equation. What percentage of the sandwich did Hannah predict was covered on Wednesday? Consider the precision of Hannah's measurements when deciding how many decimal places to use in your answer. So I don't think this is what they intend right now, but I want to show you how to get a nonlinear model for your calculator. So I'm going to come in here and I'm going to clear this, and then I'm going to go back into stats and calc, and instead of doing a linear regression right here, I'm going to do a not quartic, not cubic, or not quadratic, not cubic, not quartic, not that one, natural log, exponential. I either want to do a power regression or an EXP sounds good. Let me try this one. Let me try 0. So there we go. Oh, it did give me a y equals a times b to the x power. Okay, that's sweet. So let's go back into our stats plot now. I'm going to turn back on the original scatter plot, and I'm going to turn off the residual plot, and then I'm going to ask it to let's see what we want to ask it to show. I need to grab the equation, so I'm going to hit this equation. Is going to be, it's stored in vars, right? Oop, nope. Yeah, it's a statistic variable. It's an equation, and it's that last regression equation I did. So you can see that's it. So to see this, I'm just going to hit zoom and then 9 again. So there is my data, and yeah, you can see the exponential model that's curving there. Now if I was to zoom out a whole bunch, go to my window and say right now I'm looking for up to 5 days. I was going to say let's look for 15 days in the future if I had a lot of these sandwiches. And let's also create Y max to be like 90. And let me look at that now. So there it is, and there's the model taking off there. Now at a certain point, right, you've got 100% of the sandwich covered in mold. There can't be any more. So fabulous. I'm just going to hit zoom 9 one last time. Look at this, and I am supposed to sketch this graph for part of my answer, so let's do that. So this was the days, number of days that it was growing, and this was the percent mold coverage. And we had a day 1, 2, 3, 4, 5. And on day 1 it was around what was it, like, what was day 1? 12%. So I'll go like 10, 20, 30, 40. So on day 1 it was around 12%. The next days it was pretty close to 12%, not much bigger. Day 3 was around, what was it, 26 and 27% and 24%. So 10, 20. So we're looking at some points in here. And then on day 4 it was 30%, close to 40, 10, 20, 30, 40. So somewhere up in here. So this is the scatter plot, and the reason why I think that let's see, let's answer these. It says create a scatter plot and sketch it. Isn't no. The data points curve. Based on the story, what kind of situation do you think best fits it? I would say an exponential model. And fit the data with an exponential model and write the equation. What percentage of the sandwich did Hannah predict was covered on Wednesday? Consider the precision. What is this? Oh, consider the precision of Hannah's measurements when deciding how many decimal places to use in your answer. Okay, so let's see. My model. Well, I can look at it. The equation was stats calc. I picked 0 exponential, and it gave us what? Okay, so I'm not gonna, I'm just gonna round to 1 decimal place, and even then I'm wondering if it should be less. The amount covered in mold is equal to the 0th term, which is about 8.2 times my multiplier of 1.3 raised to the x power. That's what I'm going to say my model says. And almost done with this question. It does say, what percentage of a sandwich did Hannah predict was covered on Wednesday? Well, Monday, so Wednesday's not here, right? She never had a Wednesday, so that would be day 1, 2. So if I put in day 3 into that model, and I'm going to use this rounded. Well, you know what? I've got the calculator here. I'm just going to go to my table. If I go to, oh my gosh, not negative days. Oh no, this has got, no, this is the model. This is, so if I come up here, yeah, day 0 was 8.2, day 3. So about 20%, just based on the rounding, right? I wouldn't claim 19.6. I'm just going to round that to the nearest whole percent. So I would say about 20% would be covered on Wednesday. Sweet. Okay, moving on. Sorry that took so long, guys. I hope if you didn't need to see that, you zipped right past that. Number 109, calculate the perimeter of a polygon that is created by these points. Okay, so to save time, I did pre-plot these points, so they're here. Although I'm always doing this mistake where I'm not quite sure I got the right points down. So let me open up the electronic book on my other screen and make sure that I can just read and verify that these are the right points. So the points we've got are there they are. So we've got the points -6, 3 is A, and then B is at -6, -3, C is -3, -3, D is 6, -2, and E is at 3, 3. That's perfect. So it says calculate just the perimeter, right? calculate the perimeter of the polygon that is created with these points. Okay, so definitely a little Pythagorean theorem here and a little not Pythagorean theorem. So the first thing I'm going to look at is just this segment AB. So along this dimension from A to B, it's the values of y that are changing, and y is ranging from 3 down to -3. So that's traveling 6 units. So I'm going to write a 6, and I'm going to circle that because that is part of the perimeter. And then from B to C, I can see that x's are where I'm changing here, and x is at -6 at B, and it goes to -3 for C. So that's a change of 3 units. So this is 3 units long. From A to E, x is 3, and it goes to no. From A to E, x is -6, and it travels all the way to +3. So that's a length of 9 units. And I can count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Then I've got these little Pythagorean bits here. This is 3 units long, and this is 1, 2, 3, 4, 5 units long. Oh, I want it to be 4 because it would be a 3, 4, 5. But it's not. So this is, again, 1, 2, 3, 4, 5. This is 5 units, and this is 3 units. So the length of segment DE, right? The length of segment DE squared is equal to 3 squared plus 5 squared. I got to square the 3, I get a 9. This gives me 25. Together this is what, 34? And DE, that's what DE squared is. So the length of DE is root 34. So part of my perimeter is going to be this square root of 34. Let me circle that. And then the final part I've got here is this from C to D. So that has a rise of 1, and then I'm going from -3 to +6. So that length along there is 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. So the length of segment CD squared is going to be 1 squared plus 9 squared, which is 1 plus 81, which is 82. So that means that the length of segment CD is going to be the square root of 82, and that's going to be part of my perimeter. So if I put all those pieces together, not manually with my calculator, for crying out loud. Let's see. I've got a 6 plus a 9 plus a root, or is that root 34 plus, well, let me throw those in later. 6 plus 9 plus 3, those are the only integers I've got. Well, I could do that. That's 9 and 9, that's 18. So I've got 18. So if I wanted to write the exact answer, right, I would write 18 plus root 34 plus root 82. You know, 34 divided by 2 is 17, right? Yeah, oh, that's not going to help. Those are both prime. Yeah, I think we're done with that. So then in terms of getting a decimal approximation, right, I can go ahead and throw those into my calculator, and my calculator tells me that I should have an area of approximately, whoops, no, not the area, the perimeter is approximately what, 18 plus it looks like that's about 32.9, and I can't remember if they gave me units on these. They didn't, right? So I'll just say units. 32.9 units is the perimeter of that polygon. 110 says, decide if the statements below are true or false. So I'll read these symbols, and as I read them aloud with the correct way to pronounce these symbols, it becomes pretty obvious. So the first one is 11 is less than -13, and that is definitely false. Right? 11 is greater than -13. B, this would be 10 is greater than or equal to 10. Well, because it's got the or equal to, it's true. right? 10 happens to be equal to 10. The word or means, of course, only one of those conditions need to be true. So is if 10 was greater than 10, it would be true, but that's not. But because 10 is equal to 10, it is true. On this next one here, we've got 2 minus 6. Uh-oh, that's negative 4 times negative 3 would be positive 12. So this is 13 is greater than 12. Well, 13 is most definitely greater than 12, so we'll say true. 4 is less than or equal to 4. Well, it's equal to it, so this is true. 9 is greater than or equal to negative 9. That's true. 9 is definitely greater than negative 9. F, negative 2 is greater than negative 2. No, that's false. It would be true if it was or equal to, but it just says it's strictly greater than, and negative 2 is not greater than itself. G, it says negative 16 is less than negative 15. Yeah, that's true, because negative 16 is definitely, if you want, just have a number line. You could say here's your 0, way over here's your negative 15, and then just to the left of that is negative 16. So as I go further to the left, the things to the left are smaller and smaller. So negative 16 is less than negative 15, so this is true. And then the final one is 0 more than 6. No, 0 is not more than 6. That's false. Okay, 111 says use the graph below to write a possible equation in y equals a times b to the x form. So first thing that I see is they are showing me, what are they showing me here? It looks like they're showing me that the point 0, this is going down a half and then over 1. So I guess the 2 points I have, it looks like this is the point, this would have to be the point 1, right? And then this is 2. But then it's going down half over 1. So they're trying to fool me, making me think about a slope triangle there, but there's a curve. So I'm not going to fall for this. The slope is that I'm not going to use negative 1/2. I'm not finding a line. So I have this point when x is 0, y is equal to 1, right? That's this point, 0, 1. And then I also have this point when x is 1, right? It looks like when x is 1, it looks like y is at just 1/2. So these are my 2 points. So if I was to start with y equals a times b to the x power and write 2 equations, I could write, first off, 1 is equal to a times b to the 0 power. And because b to the 0 power equals exactly 1, I just wrote down what a is, right? So a, my 0th term is 1, and I knew that anyways, because I can see where it's going through there. So a is 1, and then my other equation is 1/2 equals a, b to the x. A is 1, and then b is, I don't know, well, I guess I do know what b is, don't I? Times a times b to the first power. B to the first power is b, so I just also wrote down what b is, right? B is 1/2. So my answer is y equals a times b to the x power. And I've left no room to see this. So right here, b is 1/2. So there you go. My 0th term is 1, and I'm multiplying by 1/2 each time. Not a negative number. It's just getting, it's half of what was. For the next question, it says each table below represents an exponential function in f of x equals a times b to the x form. Copy and complete each table on your paper, and then write an equation for the function. So the next problem does ask us to copy down this table and then to complete it and then come up with an equation in the form y, or f of x equals a times b to the x. So I've copied the table down here. This is my handwriting, and I need to figure out what my multiplier is. And actually, once I figure out my multiplier, I should be able to figure out what this zeroth term is. So that would give me the value of a. And here's what I know. If I start with the number 3 and I multiply by my multiplier, I don't know what it is, but I'll just call it b. If I multiply by that twice, times a b times another b, I will get the number 75. So what I'm looking for is, I'm basically solving this. 3 times bb, 3 times b squared is 75. If I solve for b squared, I've got b squared is 25. And actually, b would have to be, right, b could be positive or negative 5, but I can see we're not dealing with negative bases for these, so the b is going to be a positive 5. So 3 times, is that true? If I take 3 times 5, I would get 15, and then if I go times 5, I get, so this is, let me fill this in with a green color. So this has to be 15, and then I can say times 5, and that would give me 375, and then times 5 would give me 1,875. So the equation, now that I know two things, right? Now that I know what my 0th term is, and now I know that I'm multiplying by 5 each time, I can write this equation. So the equation for that sequence is y equals my 0th term, 15, times b, which is 5 raised to the x power. They said write it in the form of f of x, so I can change this. I can say f of x equals 15 times 5 raised to the x power. Cool. Let's do that for the next problem. Oh dear. Well, something that's nice, because these are next door neighbors, right? I can figure out what b is, because if I take the number 96.64 and I multiply by a b, right, just the one b, then I should get the number 77.312. So in order for me to solve that, I'm just going to divide 77.312. I'm going to divide that by 96.64, and I'm 64, and I'm going to get 0.8. So my multiplier is just 0.8. Nice to know, because now I can go backwards in time. If I'm going forward by multiplying by 0.8, I can go backwards by dividing by it. So let me go ahead and go forward one more time, right? 77.312 times 0.8 gives me gives me this number. It gives me, I'll write this in green, it gives me 61.8496. 61.8496. Now if I take that and I divide by 0.8, it lets me go backwards. Yeah, that's right. And then I do it again, I go backwards. Yeah, do it again, I'm at 120.8, 120.8, and then I'll divide it one more time by 0.8, and I'm at 151. So now I have everything that I need to write down the equation, right? I know my 0th term is 151, and I know that every single time I move forward, I'm multiplying by 0.8. So this is a situation where something's decreasing by 20%, right? Because my multiplier is 0.8. So the equation for this would be f of x is equal to my 0th term, 151, times 0.8 raised to the x power. Okay, in problem 113 it says use the angle relationships in the diagram below to determine the value of each variable. Name which geometric relationships you use. So I'm going to give the values, and then I'm going to name relationships that I'm using at the same time. So one of the first things I see is this well, I see a pair of vertical angles that I'm going to focus on, I think. Well, one thing I could do is, because these lines are parallel, right? I know that angle D, this angle, and 63 have to be the same. Nope, they don't have to be the same. They're not corresponding. Those two would have to be, they're same side exterior angles. They have to be supplementary. This angle right here would have to be 63 because this angle corresponds to the 63. So I could say that D plus 63 is 180, and if I take 180 and I subtract from that 63, I get 117. So I believe that the measure of angle D is 117 degrees. And the property that I used there was I used I used a couple things, right? I used corresponding angles. I used corresponding angles, and I used linear pairs. The linear pairs add up to 180. So all right, corresponding angles, and I used a linear pair. Okay, so that's D. Let's see if I can figure out some more of these angles. I know that whatever they are, I know that C and A are going to be the same. Oh, and I also know this. Let me make this. These lines right here intersect. I know that some vertical angles here. I've got that the 63 degrees has to be equal to the 37 degrees plus A. And why is that? That's because the 37 and the A together is a vertical angle with 63. So I'll write vertical angles. And to solve for A, I'll take away 37. So I've got 63 minus 37. So you get 26 degrees. So the measure of angle A has to be 26 degrees. That's nice. And because we got that, now we also got C, because C and A are alternate interior angles. Alt interior angles. That lets me say that the measure of angle C is also 26 degrees. Okay. And what the final thing I'm gonna do is I'm gonna look at this whole big triangle that I'm gonna highlight in this purple color. This whole big triangle. And I know that the three angles in that triangle have to add up to 180. And part of those angles is I've got angle B. I've got the measurement angle B. I've got plus. There's this 37, and then the other angle is together with the 52 degree and the 26 from C. So all of these angles have to add up to 180, and it looks like I've got more than three angles in a triangle, and that's not what's happening. What I've got is this is an angle, this is an angle, and then these two together are a third angle. So I'm just going to again rely on my friend, the TI-84 plus, take the 180, and I'm going to subtract from that 37, and I'm going to subtract from that 52, and I'm going to subtract from that 26, and I get exactly 65. So I get here that the measure of angle B is 65 degrees. Okay, so that's all the pieces there, right? We've got the measure of angle D, we've got the measure of angle A, we've got the measure of angle C, and we've also got the measure of angle B. And I've also included reasons why. Oh, the one reason I didn't write down is this is the triangle angle sum theorem. THEOREM, which just says the three angles in a triangle add up to 180 degrees. The last question, 114, is a checkpoint for solving problems by writing equations. It's referred to as checkpoint 6b in the textbook. And one of the things about the checkpoints is always that check your answers by referring to checkpoint 8b materials in the book. It says ideally at this point you should be pretty comfortable with these and getting them right. If you don't, they do suggest some extra problems you might want to take a look at. So because of the nature of this problem, we're just going to do one of them. In fact, we'll do the first one. If you're disappointed in that, come by and we'll do another one in class together at lunch or something. So it says the Lees have 3 children. Okay, so 3 children. The oldest is twice as old as the youngest. So right off the bat, they are telling me I would use the youngest child's age to figure out the oldest, right? So I'm going to write my let statement in terms of the youngest. I'm going to say let x be the age of the youngest child. Okay, so if x is the age of the youngest child, it says the oldest is twice as old as the youngest. So that means that 2x, right, is the age of the oldest child. And then it says the middle child is 5 years younger. No, the middle child is 5 years older than the youngest. Okay, so 5 years older. So I've got the x, and I'm going to add 5 to that. So this would be the age of the middle child. What is it? It does say the middle child. The middle. Okay, so we have either a variable, right, x, that expresses the age of the youngest, and then we have 2 different expressions. 2x is the oldest child and x plus 5 is the middle child. It says the sum of their ages is 57. How old is each child? Oh, piece of cake, right? So the equation would be an x plus a 2x. So that's the youngest child plus the oldest child plus x plus 5. That's the middle child, and that has to equal 57. So what makes this problem so doable is just defining your variable and then writing these expressions like this. So when I look at all this together, I've got 1, 2, 3, 4x plus 5 equals 57. And I know you guys could solve for x. You could have done this anyways. Solve for x and then basically use that to figure out x will be the youngest child, twice that will be the oldest, and whatever x is plus 5 will be the middle child. So that's it. See you in class. And I hope you found this modestly helpful. Sorry about all the calculator stuff at the beginning.